Suppose that in a certain company, 5% of the employees use drugs. The company decides to test all of its employees for drugs with a test that is 95% successful, i.e. it correctly identifies 95% of the drug users as users and 95% of the non-users as non-users. We're going to let D equal the event that employees use drugs and P the event that I would test positive. Express the information in terms of P and D. Well, the probability of using drugs is 5%, which means drug complement is 95%. And then the probability of testing positive given you use drugs is 95%. That comes from here. It correctly identifies 95% of users as users, so positive would get a positive. And then a non-positive, if you don't use drugs, you would get a non-positive, so that would also be 95%. Now we're going to fill out our tree diagram. We start with the top. Probability of using drugs is 5%, so then not using drugs would be 95%. Then if you use drugs, the probability of you actually getting caught, okay, is 95% if they test you. With a 5% chance that you get away with it, you get a negative even though you use drugs. Vice versa, if you don't use drugs, the probability of getting a positive is 5%, but of coming up negative like you should be is 95%. Using this tree will help answer the rest of the questions. I went ahead and just copied the tree from up here into this corner so we can look at it. And the first question said was, what is the probability that a person uses drugs and tests positive? So drugs and positive. That's the multiplication rule. So that's the probability of drugs times the probability of positive given drugs, which would be this little bit right here. So you don't always have to write these formulas out, but that's the formula. So drugs is 0.05 times positive given drugs, that's 0.95, and the probability of doing both, 0.0475. And then it says, what is the probability that a person tests positive? Well, there are two ways to test positive. You could be a druggie and test positive, or you could not do drugs, but you're unlucky and you still test positive. So we have to look at it both ways. Probability of drug and positive, or the probability of no drugs and positive. And that would give us the probability of being positive. We have to do it this way because we only know the positives based off of if they do drugs or not. So we have to break it up into the two ways to do it. And so if I look at that, drugs and positive, that's the 0.05 times the 0.95, or not drugs, that's 0.95 times the chance of testing positive if you don't do drugs, which is 0.05, which is about 0.095, okay, or 9.5%. Now it says, what is the probability that a person uses drugs or tests positive? Okay, so probability of drugs or positive. Well, that's going to be our addition formula. Drugs or positive, that's the probability of drugs plus the probability of positive minus the overlap, because these people that are using drugs have already been counted even though they tested positive. So the probability of using drugs is 0.05 plus the probability of testing positive, which is up here, 0.095, minus the overlap, drugs and positive, 0.0475, and you get 0.0975 or 9.75%. Okay, last question. If a person tests positive, what is the probability that they use drugs? Well, that is a given. We know that they tested positive, so we have the probability that they use drugs given that they tested positive. Well, that's our formula, the probability of drugs and positive, all over just the probability of testing positive. Well, we already know that drugs and positive are 0.0475, just the chance of testing positive in itself, 0.095, and you might be surprised to see that it's 50% chance. So if a person tests positive, there's only a 50% chance that they actually use drugs. That other 50% would be considered a false negative. And we're going to talk about that part in class next time.